So our next organic chemistry A2 topic is about nitrogen compounds. The simplest one are amines. You can think of amines as being related to the inorganic molecule ammonia. They smell fishy. This isn't great. It's a horrible smell, very unpleasant. If you've got decaying, rotting fish, like at Ipswich market at the end of the day, you will notice an unpleasant fishy odour. This is because as the protein in the fish breaks down, amines are released, with beautiful names like cadaverine, putrescine. We'll come back to those. So from the specification, you need to know how amines, just like ammonia, are basic. We can consider the relative basicity of primary and secondary amines for some stretch material. Like any bases, they react with acids, and you should be able to construct equations with an amine and an acid to make a salt. You'll need to know how to prepare an aliphatic amine, and this is a revision of a lower six topic involving the nucleophilic substitution of haloalkanes with ethanolic ammonia. You also need to know how to prepare aromatic amines, and we're going to do this by a reduction reaction with nitroarenes using tin and concentrated hydrochloric acid. Looking at a molecule of ammonia, you may recall that it has a trigonal pyramidal shape. This is because there are three bonded pairs and, importantly, a lone pair of electrons. The lone pair of electrons can accept a hydrogen ion, and this is how ammonia acts as a base. The simplest amines, like methylamine or ethylamine, are formed when one of the hydrogens of an ammonia molecule are substituted with an alkyl chain. So you should be able to recognise and name simple primary amines. CH3NH2 would be called methylamine or 1-aminomethane. CH3, CH2, NH2 got ethylamine or 1-aminoethane. CH3, CH2, CH2, NH2 got propylamine or 1-aminopropane. The fourth example here is still a primary amine because the nitrogen has two hydrogens and only one of them has been substituted with an alkyl group. This needs to be named 2-aminopropane. You'll note how this is different from alcohols. This is not a secondary amine. If that NH2 was an OH, it would be a secondary alcohol because the carbon would be attached to two other carbons. But in this example, for amines, a primary amine is determined by the number of hydrogens that have been substituted for carbons. If we have a look at the secondary amines, the simplest one we can call dimethylamine. You'll notice it's just like an ammonia molecule, but two of the hydrogens have been substituted for carbon groups. We've also got diethylamine, where instead of being substituted with methyl groups, we have ethyl groups. You could, of course, have things like methyl ethylamine or propyl butylamine. There are many possibilities. A tertiary amine is like a molecule of ammonia, but all three of the hydrogens have been substituted for carbon groups. The simplest one would be trimethylamine. If you look at the spatial arrangement, you can see just like ammonia, it still has a trigonal pyramidal shape with 3 bonded pairs and 1 lone pair. Ideally, of course, you'd use a wedge and dashes to show the spatial arrangement. And if we were to get our protractor, we would find it's 107 degrees between the methyl groups. So the naturally occurring amines with fantastic names like putrescine and cadaverine can be found in things like the Indonesian corpse flower. This extraordinary huge flower flowers very irregularly and emits a foul odour to attract insects. It's a carnivorous plant, and the smell of rotting flesh can be detected to try and attract the insects with chemicals such as the putrescine and cadaverine. Putrescine would be more commonly called 1,4-diaminobutane, and the cadaverine we've got 1,5-diaminopentane. If you were to come across a lion looking at you like this, I'm sure your heartbeat would start to rise as adrenaline starts to course through your body. You can see that this is a secondary amine because 2 of the hydrogens on the nitrogen have been substituted for carbon groups. You'll notice also a secondary alcohol and 2 phenol groups. Amines are also used widely in medicine. This is amphetamine. It is legally allowed to be used to treat things like drowsiness or chronic fatigue syndrome. Similar amphetamines are also available illegally as stimulants. The drug speed, for example, is an amphetamine. It will make you talk too fast, your heart beat too fast, but you'll be buzzing and full of energy and be able to dance all night long. This will put undue stress on your heart and your body and has caused fatalities. You can see from the structure of the amphetamine, it is a primary amine. Phenylephrine is used in nasal sprays and products like Lemsip as a decongestant. You can see that this is a secondary amine and also a secondary alcohol and a phenol. In fact, it's remarkably similar to the structure of adrenaline. So when you're naming amines, the end will always end in amine. And if you're drawing butylamine, rather than drawing a displayed formula, you should be confident drawing a skeletal formula. And you can see those here. For secondary amines, you need to determine the root by naming the two alkyl chains. Add any prefixes for additional groups and write them in alphabetical order. Finally, add the suffix amine. As the alkyl groups are attached to the nitrogen atom, secondary amines are often called N-substituted, and this is given as a prefix to the name. For example, we've got N-methyl propylamine, meaning that the ammonia molecule has got one hydrogen substituted with a methyl group and one substituted with a propyl group. Obviously, naming gets more and more complicated, but if you look at this structure, we've got a secondary amine with a branched alkane. So a suitable name would be, for tertiary amines, determine the root by naming the three alkyl chains. Amine. If there is more than one of the same group, means add the appropriate prefix substituted or directly on the nitrogen group. If you're drawing NN diethyl propylamine, you can see that there are two ethyl groups substituted on the nitrogen and one propyl group substituted on the nitrogen. So just like ammonia, amines are bases. Ammonia is quite a weak base. When an amine neutralizes an acid by accepting a proton or an alkyl ammonium as such, we can call it a Bronsted-Lowry base. Ethyl amine, if you want to use the Lewis definition, we get an electron ammonium ion because it donates with hydrochloric acid to have ethyl ammonium chloride, or with nitric acid. And phenylamine would have phenyl ammonium nitrate. You need to practice a few of these. As a word equation, they're very straightforward, but you should be able to write structural formulae. Ethylamine and hydrochloric acid will give you ethyl ammonium chloride. Why don't you try your own? They all follow the same pattern, that when you've got your alkyl amine, it will end in the alkyl ammonium salt. To prepare a primary aliphatic amine, quite specific conditions are required. You need to warm a haloalkane with ammonia dissolved in ethanol. You can't use a reflux apparatus because the ammonia would escape out the top of the condenser. Therefore, it needs to be sealed in a tube and warmed. Clearly, the pressure will build up and this will be quite dangerous. You should use also excess ammonia because this will limit the formation of the amine rather than just the salt. To make this clearer, it's probably worth showing this in two stages. When the chloropropane, for example, is warmed with ammonia dissolved in ethanol in a sealed tube, it will first form the salt, that is propyl ammonium chloride. But if the propyl ammonium chloride is then further heated with ammonia, it will make your propyl amine plus ammonium chloride. The mechanism, which you should be able to recall from your lower six, is that haloalkanes undergo nucleophilic substitution. This mechanism diagram shown here is missing a dipole, and it's quite important that you show a dipole between the C and your halogen, for example, chlorine. with the carbon being slightly positive and the chlorine being slightly negative. Then the lone pair on the nitrogen in ammonia can be donated to the slightly positive carbon, whilst the bond between the carbon and the halogen breaks. Because primary amines still have a lone pair of electrons on the nitrogen, this can act as a nucleophile, which means it could react with more of your haloalkane. If it does this, it will form a secondary amine, which could then form a tertiary amine, which indeed could form a quaternary ammonium salt, which is beyond our specification. To try and minimise the formation of other products, if you're trying to prepare a primary amine, it's important to use an excess of ammonia. That way a collision is more likely between a haloalkane and ammonia rather than a haloalkane and your newly formed primary amine. Have a go at these practice questions. Check your answers carefully. I hope you remembered that distillation or chromatography are a good general way of separating organic molecules. How about preparing an aromatic amine? For example, would benzene and ammonia be attracted? If you think about it, the lone pair on the nitrogen would not be attracted to the delocalized pi system of electrons. So there must be a different mechanism at work. You should recall from our benzene topic that you can make quite easily nitrobenzene from benzene with concentrated nitric and concentrated sulfuric acid, keeping the temperature at about 50 degrees C to prevent multiple substitutions. When you've got your nitrobenzene, then you can reduce it. The reducing agent used to convert nitrobenzene into phenylamine is tin with concentrated hydrochloric acid. This needs to be refluxed at 100 degrees C. Because it's using an acid with an amine, you will find you'll get the phenylammonium salt. But if you add subsequently sodium hydroxide, and that's important, it's subsequently rather than at the same time, this will neutralize the hydrochloric acid and deprotonate the phenylammonium salt to give you your desired phenylamine. This mixture of products can then be separated by steam distillation or maybe solvent extraction to acquire your desired phenylamine.